Topic 4, we're going to talk about special cases again. So we talked about special cases when we were factoring quadratic trinomials where a was exactly 1. We need to revisit that idea of special cases now that we're talking about factoring quadratic trinomials where a is not 1. So the special cases have not changed. We're going to have a situation where our lead coefficient is negative. We're going to have a situation where we have a GCF. We're going to look at a prime quadratic trinomial, and then we'll look at a situation with 2 variables. The 2 variables is probably the one that shows up the least, but I want to make sure you know it just in case it comes up in your homework. Okay, so the directions here for example 4 just say factor each polynomial completely. So looking at part A, we have negative 8x squared minus 33x minus 4. What you need to remember is if the lead term is negative, factor out a GCF of -1. So if there is no GCF, but you do have that lead term that's negative, you have to factor out the -1. Otherwise, our factoring method just doesn't work quite right. So 8x squared, 33x, 4, they have no common factor, but we still need to factor out the -1. So I'm going to write this as -1 and then a set of parentheses. And basically, when you factor out a -1, all it does is change your signs. So it's going to make this 8x squared plus 33x, whoops, plus 33x plus 4. And then at this point, we're just going to pick up with the AC method. So A times C is 8 times 4, or 32. We want factors of 32, so both positive or both negative, that have a sum of 33. So hopefully this one's pretty easy. We do want positive factors in this case because we want a sum of positive 33. So the first pair of factors is 32 and 1, and that just so happens to equal 33, so we can stop there. We don't even have to look at the other factors. This is it. So I've got to keep my negative that I've already factored out. And then I'm going to rewrite the polynomial by breaking down 33x and writing it as 32x plus 1x. And then I can factor by grouping. So as you factor by grouping, just never forget that you've got that -1 that you factored out. So it has to be a part of this process from start to finish. So looking at the first half of the polynomial inside brackets, we have 8x plus 32. Well, 8x and 32 have let's see, an 8x in common. So we need to factor out 8x. So I'm going to divide both of these by 8x. Well, 8x squared divided by 8x, the 8's cancel to become 1, and then x squared minus x is just x. 32x divided by 8x, the x's cancel to become 1, and then 32 divided by 8 is 4. Now, in the previous video, we looked at a situation where it didn't look like we had a GCF, but we were factored by grouping. And when you're factored by grouping, you have to factor something out of each half. So looking at x plus 4, they have no common factor. So I need to factor out either a 1 or a -1 and let the lead term tell you which. Since my lead term here is positive, I'm going to factor out a positive 1. So I'm going to go down here and go plus 1. And then, whoops. And then I divide each of those terms by 1. Nothing really happens. X divided by 1 is x. 4 divided by 1 is 4. But hopefully you can see that inside the brackets, the two terms that we have a common factor of x plus 4. So we need to write down our original GCF of -1. I'm just going to write it as a minus. We need to write down our second GCF of x plus 4. Then we need a set of parentheses for everything that's left over. So when I divide up here by x plus 4, I'm left with just 8x. When I divide over here by x plus 4, I'm left with just 1. So this is my final answer. And the way you would check this is the same. You would just FOIL, but you have this extra factor of -1. So if you did want to check this, you could FOIL the two binomials. So we would get 8x squared plus x plus 32x plus 4. That would give me 8x squared plus 33x plus 4. And then you've got that -1 that you've got to distribute through. So we end up with -8x squared minus 33x minus 4, which is exactly what we started with. Okay, just make sure if you factor out a negative because your lead term is negative, that negative has to follow you through the whole problem. It has to be part of your final answer. All right. Part B, we have 4x to the third minus 18x squared minus 10x. Right off the bat, I notice I have a third degree polynomial, not a second degree polynomial. And we're talking specifically about quadratic trinomials, which means the highest exponent on a variable should be 2. So we know we have a GCF that has at least an x in it. All the terms have an x. And then looking at 4, 18, and 10, I always start with the smallest coefficient. Well, 4 doesn't go into 18, it doesn't go into 10, so 4 is not part of the GCF. But then I want to start breaking down 4, and I want to look at factors of 4. Well, the factors of 4 would be 2. Well, 2 goes into 18, 2 also goes into 10, so that means my GCF here is 2x. So I'm going to factor out to start with a 2x, and that's going to leave me with 2x squared minus 9x minus 5. I want you to get really kind of comfortable factoring out a GCF so we don't have to go through it step by step every time. So that's what you're going to get there. If you need to pause the video and verify that's what you get, do so. But now we need to do the AC method. Well, A is now positive 2, C is negative 5, so A times C is negative 10. We need factors of negative 10 that have a sum of negative 9. Now, to get factors of negative 10, one has to be positive, one has to be negative. So we could try for negative 10 and 1. Well, we can stop there. Negative 10 and 1 happens to be the magic pair that has a sum of negative 9. So I've got my 2x outside brackets, and then inside the brackets, I'm going to rewrite 9x. So I get 2x squared minus 10x plus x minus 5. Make sure you carry your 2x through the whole way. All right. We need to start our factor by grouping. So we split this down the middle. And looking at the first two terms, I have a GCF of 2x. I divide each of these by 2x, leaving me with an x minus 5. Again, pause the video and make sure you understand where the x minus 5 came from. Looking at the last two terms, they don't have a GCF. So if I don't have a GCF, I have to factor out a 1 or a negative 1. Since my lead term is positive, I'm going to factor out a 1. That leaves me with x minus 5. So I have my original GCF of 2x. I have my new GCF inside the brackets of x minus 5. And then I divide the inside halves by x minus 5. And that leaves me with 2x plus 1. So what I would do here to check, I would FOIL the two binomials. And then once you get those FOILed, distribute a 2x through. Okay, you can stop the video and FOIL that one on your own and see if you can check it out. Part C, we have no GCF. There's no negative lead term, so we can just go ahead and start the AC method. So A times C is 9 times 2, or 18. So we need factors of 18 that are both positive or both negative. We need a sum of 3 so we can look at just positive factors. But let's just list all the factors here just to be safe. So we have 18 and 1, or negative 18 and negative 1. We have 9 and 2, negative 9, negative 2. We have 6 and 3, negative 6, negative 3. And I think those are all the factor pairs. So let's see if any of these add up correctly. Well, we would get 19, 11, 9, negative 19, negative 11, negative 9. What does this mean? Well, we have a situation where the product A times C does not have any factor pairs that have a sum of 3. There's no way to add any of these factor pairs and ever get a positive 3. So what we would have to say here is that this polynomial is prime. It cannot be factored with integers. Okay? Last up, finally, we get to 3x squared minus 10xy plus 7x. So we saw an example like this before when we were doing factoring quadratic trinomials where a was 1. And we basically set up our two binomials where each started with an x and each ended with a y. It actually works out a little bit differently here. It just works out. It just works itself out in the mix. You don't have to worry about placing a y anywhere. It just sort of factors on its own. So we're still going to do the AC method. So we look at a times c, which is 3 times 7, or 21. Now we have positive 21. That means we need positive factors or negative factors. So we could have 21 and 1, negative 21, negative 1. We could have, let's see, 7 and 3, or negative 7 and negative 3. Now, you can automatically eliminate half your list. We know that our factors have to have the same sign, both positive or both negative. But we need a sum of negative 10. There's no way to add positive factors and get a negative sum. So we can eliminate the first half of the list. Now, looking at the second half of the list, we have sums of negative 22 and negative 10. So we're going to stick with negative 7 and negative 3. So when I rewrite this, I'm going to leave the squared term and the y term alone. The middle term, the negative 10xy, I'm going to break it down into two terms using negative 7 and negative 3 as my coefficients, and just make sure each of those terms has an xy, and then when you factor, everything works out. So we get 3x squared. Let's do minus 3xy minus 7xy plus 7y squared. We factor by grouping. So looking at the first two terms, they have a 3x in common. So when I divide by 3x, let's see, I'm left with x minus y. Looking at the second two terms, I definitely have a GCF of 7y, and because my lead term is negative, I want to make that GCF negative 7y. Well, negative 7xy divided by negative 7y is just x. 7y squared divided by negative 7y is negative y. I hope you can see that we have this binomial factor in common. So that's my GCF is x minus y. And then when I divide by x minus y, the x minus y's cancel on both halves, leaving just a 1. 1 times 3x is 3x. 1 times negative 7y is negative 7y. And again, you can FOIL that to check your work. So make sure you know how to factor quadratic trinomials. Where a is 1, those are going to be quicker and easier. You have a shortcut. You don't have to do as much work. When a is not 1, it's a little more work if you do the AC method. Like I said before, you can certainly investigate other methods like trial and error. I do find that students tend to be the most successful here. That's why this is the method that I teach.